Hey guys, so let's discuss new round, new interview video, which is the round 6 of Microsoft interview loop, and it is a low-level design round where the question is design a meeting scheduling system similar to Calendly, Google Calendar, or Microsoft Outlook Calendar. Okay, so here you need to design meeting scheduling system. Now, the step one, what will be the functional requirement here? Let's discuss. So the system should support create meeting, update meeting, cancel meeting. Okay, then invite attendees, accept or decline invitation, recurring meeting. Let's say every day, 8 o'clock Scrum call. Okay, 8 p.m. So now calendar conflict detection, reminder notification, waiting list, and time zone support. So time zone support, let's say your team is working from US, you're working from India, so there will be a time zone time difference, right? So time zone support should be there. And then non-functional requirements, so this will be common for all the systems like low latency, high availability, thread safety, extensible design. In future you can add new features, okay, in the system. And so your existing system should not break, or you should not change the existing system, just plug and play kind of thing. Okay, so you can extend your you can extend features in your system, extensible design. And then easy testing and clean APIs. Now, what software engineer which has 2 to 5 years of experience will answer for this? So we will be seeing the answer based on three roles. The first one is software engineer, senior software engineer, and architect. Okay, so what software engineer which will who will have 2 to 5 years of experience, he would be expected to answer, as this is the low level design, we will be seeing here class diagram, database design, and then the APIs also. Okay, software engineer will say that I will design this scheduling using object-oriented principle. Okay, the main entities are user, calendar, meeting, participant, and scheduler services. Okay, so now UML diagram, if you see, so in UML diagram, let's say you have one user, okay, and the ID is of type UUID. Why we are using UUID? We will see that. Okay, he will have a name and email attribute. Now you will second class you would be having calendar. Okay, so which will have the meetings, which is nothing but the list of meetings. Now what is meeting? Meeting is one another entity which will have ID, title, start time, end time, organizer, attendees. Okay, which will be the list of user, and then status. Okay, meeting status. So now again, next you will have a participant. So participants will have the user. Okay, and then it's a response, like response status. So now here, I told you that we will be using UUID. Why we are using UUID? So see, we use UUID, universally unique identifier, to generate an ID that is globally unique without coordinating with central database. Okay, so globally unique ID it will produce every time. Let's say you have two messages, okay, and if their ID is same, then they will process right at the same time. It should not happen. All message ID should be unique. So why we use UUID? See, suppose you are building a chat application like Slack. Okay, if two servers both generate message IDs using auto increment, so let's say server A generate message ID 1001, server B will generate 1001. So now when data is merged, you have a collision. Okay, so with UUID it will generate UUID something like this. Okay, hexadecimal format, and hexadecimal means 0 to 9 and then A to F. So here A to F, and that too small a to F. Okay, so 0 to 9 character will come there, and then a small a to F. So server A will generate something like this, and server B will generate something like this, unique code. Okay, so both IDs are unique and there is no conflict. So benefits of UUID: globally unique across all the servers. Okay, no central ID generator required, works well in distributed systems, and easy to merge data from multiple regions, and clients can generate IDs even when offline. Okay, so now if you talk about the classes here, so first class you will have user class, okay, which will have ID, name, and email ID. And then second class you will have a meeting, which will have ID, title, start time, end time, organizer, and then list of user attendees. Okay, third one is the calendar, so it will have a owner of type user, and then list of meetings. Okay, so now here scheduler service will have few important APIs like create meeting, cancel meeting, update meeting, okay, then get meetings, which will return you the list of meetings, and then has conflict. It will check if you're scheduling meeting, okay, so attendees should not have a conflict. Okay. Now, REST API, which all APIs you will be using. So slash meeting post type, okay, which will store the new, create the new meeting, right? And then put update the meeting, delete, okay. Then get all the meetings, get particular meeting, and then get calendar for that particular user, okay. And then whether the user will accept the request, okay, user ID, and then accept, and then he can decline also. So these kind of important APIs would be there. Now senior software engineer will expected to answer that beyond the basic object model, so whatever software engineer said, you need to say that. Apart from that, uh, I would focus on extensibility, concurrency, okay, and then validation, notification, and clean separation of responsibilities. So now, production architecture, if you see, so how it will look like, see, APIs will go to meeting service, okay. Now meeting service will have multiple different services, like calendar service, notification service, conflict validator, okay. It will check the conflict and resolve it, reminder scheduling, and then recurring meeting engine, and then all will go and communicate to database, okay. So see, the design goal here is it should be loose coupling, okay. It should be loosely coupled. If you change in one service, so another service should not affect. That's why you have created different services here, right? And then high cohesion. What is high cohesion? One component and one clear responsibility. So for example, this is calendar service, it will responsible for calendar related things, and then this is notification service, so it will be related to sending email and all, right? Then extensible module, tomorrow you can again add one module here, okay. Then independent services, these all services are independent. Easy testing. Now principal engineer or architect, which has this 12 plus years of experience, what he will be answering that for enterprise collaboration platform like Microsoft Teams or Outlook, I would separate scheduling, okay, notification, recurrence, and availability into independent services communicating asynchronously. So he's saying that he's saying the same thing, loosely coupled, okay. So independent services he will create for all these things, and this allows each capability to scale independently while remaining maintainability. So how it will look like, see, the enterprise architecture will look like this. Client will schedule a meeting, okay. It will go to API gateway where it will route that particular request to a correct service, or authentication or rate limiting will get performed there. After that, it will go to different services like meeting service, calendar, availability, which will check the availability of the user, then notification, reminder scheduler, and audit service. Now from here, it will go to messaging queue, okay, and from there asynchronous communication or event streaming happen, and then it will go to database for the persistent storage. Now there you can use SQL, NoSQL, anything, okay. So guiding principle, if you talk about here, service isolation, okay, event driven communication, here you have used the messaging queue, scalability, reliability, extensibility, and observability. Okay, now let's talk about few follow-up questions. So we will be talking 10 follow-up questions here. So first one is recurring meetings, okay, the meeting which is happening on recurrence basis, okay, like every day, every week, every month, okay, like town hall meeting, let's say. So that kind of thing. So how you will handle that kind of meeting? See, so software engineer will say that store recurrence information, like whether it is daily, weekly, monthly, or it is a custom, okay. So senior software engineer will say that use recurrence rule instead of storing every occurrences. So if I have scheduled a meeting, let's say scrum call every day 8 p.m, so it should store based on the rule, okay, and not that every day I will just count 8 p.m till 1 year, something like that. So for example, every Monday 10 a.m until 31st December generate instance dynamically. So dynamically it will generate the meeting, okay, not it will store at once only. And then principal architect will say that support standards such as R rule, okay. So R rule is nothing, iCalendar generate occurrences lazily while caching upcoming meetings for performance. So we cache a few upcoming meetings, right, so that the performance will be good. So that time only it will generate the occurrence lazily. Okay, follow-up 2 is related to time zone, which is very important. Okay, so see, software engineer will say that store all the meeting times in UTC. What is UTC? UTC stands for Coordinated Universal Time. So see, it is the world's primary time standard used to regulate clocks and time across the globe. UTC does not change with seasons, like no daylight saving time. Okay, for example, like IST is UTC plus 5.3. 30, like if in IST it is 1 o'clock, so in UTC it will be 1 plus 5.30 means 6:30. So similarly, London during winter it is UTC plus 0, and Japan Standard Time JST it is UTC plus 9. Now UTC is widely used in aviation, computing, GPS, weather forecasting, and international communication to avoid confusion between different time zones. Okay, so here you're scheduling meeting for different stakeholders. Okay, and they are in a, like someone is from US, someone is from UK, they will have a different time zones, right? So for this international communication we use UTC here, and because UTC provides one universal time reference, avoiding error caused by different time zones and daylight saving changes. Okay, one line explanation if you see, so store all meeting time in UTC, keep a single consistent timestamp regardless of where users are located, convert to the user local time zone when displaying. Okay, so now when it is displaying on my system, it will convert it to my local time zone, like Asia, IST. Okay, show that meeting in each user's local time for a correct and familiar experiences. Okay, senior software engineer will say that use Java's zone date time to correctly handle daylight saving changes. Okay, principal architect will say that always persist UTC with time zone metadata. Okay, now here with UTC you have to persist some metadata also, time zone metadata. Okay, store the meeting time UTC along with the original time zone, for example Asia or Kolkata, America or New York, this kind of thing, right? So this ensures consistent scheduling across regions and avoid daylight saving issues, right? So UTC provides a single source of truth, while the time zone metadata lets the system correctly display and recalculate recurring meeting even when daylight saving DST changes. So if DST changes, you know that okay, for America or New York he has to convert it this way, or for IST he has to convert this way. For example, a meeting is created in New York 10 a.m. Okay, so it will store in UTC time something like this, like 15.0000. Okay, and then time zone is America or New York. So now if New York switches between EST, Eastern Time Standard Time, to EDT, like Eastern Daylight Time, if daylight time happens there, due to daylight saving, the system still knows the meeting belongs to the America or New York time zone. You can correctly calculate future occurrences. Okay, so now follow-up question 3 is related to calendar conflicts, how you will resolve the calendar conflicts. So you will first check that existing meeting, whether it is overlapping on something. Okay, if it is overlapping, then just reject it. Senior software engineer will say that he will use the conflict condition, like your meetings new start time, new meetings time, start time is less, if it is less than existing meeting. Okay, and new meetings end time is greater than existing start time. So it means that there is some overlap, right? um, so it means that this is your new meeting start time. Okay, 1 o'clock, and this is your 2 o'clock is your existing meeting, and then this is new meetings end time, which is, let's say, 3 o'clock. Okay, and this is existing meetings, it is greater than existing meetings, so existing is here, and let's say this is 3 and this is 4. So if you are scheduling meeting from 1 to 4 but you already have 2 to 3, then it is a conflict, right? So that is what he is checking here with this two condition. Now principal or architect will say that support configurable policies allowing user to permit overlapping meetings and enforce strict conflict prevention. Okay, so he can overlap the meeting also. I can overlap this, so this one will get rejected. Support configurable policies means allow user or organization to choose whether overlapping meetings are allowed or blocked. Okay, and then allow overlapping meetings. Users can book multiple meetings at the same time if they prefer. Okay, now enforce strict conflict prevention. What does that mean? The system rejects any meeting that overlaps with an existing one. Now follow-up question 4 is reminder notification. Okay, so software engineers send reminders before the meeting. Senior software engineer will say the flow would be like this. Meeting, okay, meeting go to scheduler. Scheduler will send the notification into the notification queue, and then it will send email notification or the push notification. Now, principal architect will say that use scheduled background job with retry policies and dead letter queue to ensure reminders are delivered reliably. So you will use the background job, okay, to send the meeting this invite, okay, reminder notification, and if it is failing, then use the retry policies. But if it is still failing, then use the dead letter queue, okay, and then manually check why it is failing. Now, follow-up 8 is related to API design. So we have seen that we will create API something like this, post meetings, which will create the new meeting, okay, then put meeting / ID, so it will update existing meeting, then delete the meeting. It will get the user calendar, and then this one will invite the user, okay, for the meeting. Now, senior software engineer will say that API should be restful, idempotent, and versioned, okay. Now, principal software engineer will say that support pagination, filtering, optimistic concurrency via e-tag or versioning, and clear error contracts. Now, follow-up question 6 is related to database schema. So this kind of database we will be creating user table, meeting table, and then participant table, okay. User table will have its own user ID, meeting table will have its own meeting ID, it's a start time, end time, okay, and then participants will have the meeting ID, user ID, and response, okay, whether he will participate or not. So something like this. Senior software engineer will say that he will index these tables based on organization ID, user ID, and start time. And principal architect will say that partition data by organizations or tenant. You can have multiple organizations also, okay. Multiple organization will use your meeting scheduling algorithm system. So store each company's meeting data separately, so one organization data is isolated from another. And archive historical meeting, so move old meetings like older than 1 year to an archive database to keep the main database smaller and faster. Okay, follow-up question 7 is design pattern. So which all design pattern you will be using? Software engineer will say that he will be using factory pattern, so to create the meeting object, okay. Senior software engineer say he will use a strategy pattern for recurrence and observer pattern for notification. Now, principal or architect will say that he will use some additional pattern like builder pattern, and then command pattern, dependency repository pattern, okay. So he will say that choose pattern only when they improve maintainability, okay. Don't use pattern just because you know few patterns and you wanted to add patterns in your application. Now, follow-up 8 is related to solid principle. So quickly revise what is solid principle. So S stand for single responsibility principle, okay. A class should have only one responsibility or one reason to change. Then next is O is open close principle, okay. So it means that code should be open for extension but closed for modification. You can extend your class, okay, but you cannot modify an existing class. L is Liskov substitution principle. It means that child can replace its a parent class without breaking the program. The fourth one is I. I is for interface segregation principle. Okay, ISP. So don't force a class to implement method it doesn't need. Okay, use small specific interfaces instead of creating one interface with 10 different methods. Just create a 5 different interfaces, which so that the other class should not unnecessarily implement that method, okay. Now, D is for dependency inversion principle. It means that it depends on abstraction interfaces, not concurrent implementation, to reduce coupling. So for example, if I am using payment service, okay, PayPal, and so payment service should be interface, okay. So today I am using object of PayPal, tomorrow I can use object of something else. So that is the dependency inversion principle. Now, software engineer will say that he will be using single responsibility, open close, and dependency inversion, okay, from this solid principle. Senior software engineer will say that each service should own one business capability and depends on abstraction rather than implementation, okay. And principal or architect will say that apply solid consistently to improve extensibility, testing, and long-term maintainability. So he will be always concentrate on long-term maintainability and scalability, and then extensibility, testing, all these things. Now, ninth one is thread safety. So how you will handle the thread safety here, because let's say you're scheduling meeting for me, but I also have some other person is also scheduling a meeting for me, okay, or for the same time. So how you will update that concurrently? So software engineer will say that use synchronize update to share calendar data. Okay, so shared calendar data, use the synchronization for that. But synchronization log the particular block, right? And then it will slow the application because other thread will have to wait. So senior software engineer will say that prefer concurrent collection. Concurrent collection means let's say concurrent hash map use, okay, or optimistic locking. Let's say for list you cannot use any concurrent collection. So for list use the optimistic locking. Optimistic locking means everybody can read it, okay, and we will associate one version to it. And whenever somebody will write it, we will just increment the version. It will check whether the version has changed. Yes, if it is changed, then it will pull the data, latest data, and then will do the write operation. So that is the optimistic locking. Okay, instead of coarse grained large section of code synchronization. So this is what I was telling. Principal architect will say that minimize shared mutable state, use immutable objects where possible, and rely on transactional boundaries for consistency. Now the 10th one, the last one, follow-up question is extensibility. So let's say tomorrow you have to add new feature in your application, okay? So software engineer will say that design interface so new meeting types can be added easily. Senior software engineer will say that like examples of virtual meeting, hybrid meetings, room booking, or AI meeting summaries, okay, you can add all these things in future. You can book this thing. And then principal architect will say that design for future capabilities such as AI scheduling assistant, okay, AI will assist you, and he will tell me that okay, this user is free from this to this time, and this one is free from this to this time, this is the overlapping, okay, so you can book you can schedule meeting for this time. And meeting transcription also, right? After that, resource management, multi-tenant deployment, and calendar federation. Now what is calendar federation? So you use interface and event driven integration to minimize changes to existing component. And now what is calendar federation? So it means that allowing different calendar system means Google Calendar, Apple Calendar, Outlook, okay, to communicate and share calendar information with each other. For example, you use Google Calendar and your colleague is using Microsoft Outlook, let's say. So you send a meeting invite, Outlook receives it, and both calendar stay synchronized. So that's it. Thank you.